Hey guys, I'm Michael,
And I'm Emma.
and today we're going to be teaching you how to cook up your very own mass extinction in just 6 easy steps.
That's right, you may have heard about a few before, like the asteroid that killed off the dinosaurs, but we reckon it could have done with some improvements. You see, that extinction only managed to kill 75% of all species on Earth, which is fairly pathetic if you ask me.
Yeah, I reckon we could improve on that slightly by modelling our example on the Permian Triassic extinction, which occurred 252 million years ago and achieved an all-time high score by killing off 90% of all species.
That's right, but if you want to properly devastate life on Earth, you're going to have to do some preparation first.
Yeah, we want to set up our world to give us the best potential of a significantly damaging extinction event. You're going to want a big bunch of volcanoes clustered together in an area the size of the United States, just like the Siberian traps 252 million years ago. And you're going to need to lay down lots of carbon-rich sediments everywhere too.
And last but not least, you're going to want a nice collection of weird species that you can merrily drive into extinction, and then you're set to go. So now the setup is done, we can get started with step 1, which is to make all your volcanoes erupt in a fiery cataclysm of death.
Sounds dramatic.
Well, volcanic activity is the vital trigger to the extinction. 252.2 million years ago, the Siberian traps started slowly extruding lava as basalt. You should do the same with your volcanoes and leave for 300,000 years. It's going to look like your extinction hasn't been successful, but at this point you want to ramp up the activity with a large magma pulse. Some of this magma won't make it to the surface. This is perfect. You should notice that instead the magma will start spreading out in the subsurface and firmly metamorphosing the carbon sediments we laid down earlier. This is going to release a lot of harmful gases, which we will need to use later on. Great! Once the magma pulse event has kick-started the extinction, we don't really need any more volcanic activity, so go ahead and stop the lava extrusion. You may notice it taking about 400,000 years before it all stops flowing from the volcanoes though. This is fine and expected.
We prepared this step earlier, so we can move on with the rest of the demonstration. So in step 1, our magma released a lot of carbon, methane, and other greenhouse gases from sediments. So in step 2, we'll make use of these to create an intense case of global warming. We're aiming to warm the average temperature of the planet from 22 to 27 degrees. We're not really sure about this part, as scientists disagree on if the warming was 5 degrees or if it was more like 8 degrees during the Permian extinction, with some even claiming that the temperature shot up to 35 degrees. Feel free to experiment at home, but we recommend that your temperature spike only takes 300,000 years to complete.
What effect should this be having on the atmosphere?
Well, if you've done everything correctly, it should be getting pretty hard to breathe right now, and if you're lucky, you'll even be seeing your first wave of extinctions. During the Permian extinction, atmospheric oxygen levels dropped from 30% to 13%, which is much less than the 20% we have in our atmosphere today. For the creatures that evolved to live in the oxygen-rich Permian environment, suddenly breathing at sea level was like breathing at the top of a 5-kilometer mountain. Most animals simply suffocated.
Now that the greenhouse gases have taken effect, there should be enough warming to significantly affect the thermohaline circulation of the ocean. Ideally, you want the temperature gradient between the poles and the equator to be non-existent so that the entire thermohaline circulation system breaks down and the mixing between the water layers stops.
Oh, and why do we want that?
Well, when mixing stops, oxygen will have no way to get to the deep ocean and will create anoxic conditions perfect for bacteria. This bacteria will produce sulfide and methane, which will then poison the ocean. Perfect to get rid of all those sea animals you're trying to kill.
Oh yes, and this would be great for our next step, when we'll be using all this sulfur stored in the deep ocean to kill off anything that survived getting suffocated from the lack of oxygen.
Exactly, everything is falling into place.
Scientists aren't exactly sure how it went down in the Permian, but we'll be using one of the more widely accepted theories that there was an underwater mountain range that divided the Tethys Ocean from the Panthalassa Ocean, which enabled the upwelling of deep ocean sulfur, as well as methane, to the surface. This sulfur was then exchanged with the atmosphere with devastating effects.
Okay, so we're going to want to place an underwater mountain range somewhere on our planet. What happens next?
Well, once all this sulfur makes it into the upper layers, it should start killing off almost all kinds of marine life and acidifying the water. Almost nothing will be safe. And the best part will be when it makes it into the atmosphere and mixes with raindrops. It'll cause devastating acid rain that strips the land almost entirely of vegetation. Although in its place springs up fungi everywhere, mushrooms for days.
To top things off, while all this is ongoing, a range of methyl chloride gases released by our volcanoes have slowly been eating away at the ozone and have finally depleted it to the point where dangerous UV rays can start killing off even more of the animals and plants which had managed to survive so far.
Exciting stuff! We're certainly starting to see some great results for our perfect extinction. By now, you should be seeing most of the life on your planet going extinct. Even the insects. Did you know that the Permian was the only mass extinction of insects?
We want to make sure as little life as possible makes it through, so that's great news.
To really ensure this extinction is the best, we want to prevent any decent chance of recovery.
Well, after most typical extinction events, it only takes between 5 to 10 million years for a full biotic recovery. After the Permian Extinction, there were about 4 to 8 million years before recovery even started.
The key to this is to prolong all the issues in the oceans for as long as possible. We want to keep the oceans warm and anoxic and full of sulfides so that the extinction remains ongoing. You want to drag this on for as long as you can because this will give you the best chance at getting the high extinction percentage you're looking for.
Great, well looks like this extinction is going to be amazing. As our final step, we want to come up with a creative name for people in the future to refer to the extinction by. For example, the Permian Extinction is often known as the Great Dying. We want something equally as horrible.
How about the No Good Day?
Excellent!
Thanks for watching everyone. We hope this how-to guide has led you in the right direction and your extinction event is one of the best of all time.